Mm-hmm.
So what is a root cause and a root cause analysis? Basically, root cause means, if any defect or any issues are there. So we need to find out the, so this, why that issue has occurred. Okay, why? So what is the mistake in the code? So to find out the root cause of the defect. Okay, so basically root cause is so finding the what causes the defect. So how you can remove that defect. So that's what root cause you're going to do, that to find out the way it occurred and what is the reason behind that. So if you want to find out the root cause and fixes that, that is called a root cause analysis, we call that. So that's a simple terminology generally, but that's not the big deal. Okay, so what is the difference between bug and defect? So there is a terminologies, okay, bug and defect. So basically a bug and defect means, so a bug and defect is, bug is an informal term, but defect is a formal term. And bug is widely used by developers and users to refer to software issues. And defect is primarily used in the context of software testing and quality assurance. So bug arises from various sources such as coding errors, design flaws, and external factors. So arises due to discrepancies between the actual behavior and specified requirements or design. So this is used in the general discussions of conversations about software problems, the bug thing, and defect is specifically discussed during the testing phase to identify the deviations from expected behavior. So defect can usually associated with the failure, and it is so not able to meet the requirements, that will be treated as a defect. And severity, you can it will be changed to severity. Minor glitches, you will give a lower severity. Critical errors, so affecting major functionality, that will give high or critical, so bugs or defects. And so bugs are addressed during development and maintenance phases, and defects identified and documented during testing and resolved before release. So bugs can be fixed without being documented as a formal issue. Defect typically documented in a defect tracking system and must be resolved and validated, and often resolved informally or though informal communication. But this requires a formal process to track, manage, and resolve the defects. So these are at least a few points. Okay, so get them, that's more than enough. And what is the difference between bug and defect? And another major thing is severity and priority. What is the difference? So severity and priority, both are, these are part of defect template, right? In the defect report, you can see severity and priority columns. Severity and priority columns. So what is severity? So severity of a defect is related to how severe a bug is. How severe bug is. Usually the severity is defined. So in terms of losses, damage to the environment, company's reputation, loss of life. So that's all, comes under severity. So how severe, for example, if something happened, a person is injured, you will ask how severe it is, right? That means how much it is affecting for him. So that's a severity. And priority means a defect which is know how urgently or how quickly you can address that and you can fix that and deploy to the servers, deploy to the environments. So we have different environments. I told you, development environment, QA environment, staging, pre-prod, and production, right? So these are all the different environments. So once you fix how quickly a bug should be fixed and deployed to the live servers, that is called priority. So when a defect is of high severity, most likely it will be high priority. If severity is high, priority also should be high. A low severity defect will normally have a low priority. So these are the points you need to remember while giving the severity and priority to the defect. So let's see some of them. So what is the high severity, high priority bug? They will ask, can you give me one high severity, high priority bug? So you can answer any one of them. And so this is the high severity, high priority means when a major part of the application is broken. Like, for example, an e-commerce website. So every customer get error message on the booking form. Cannot place the orders. The product page throws a 500 error response. So then you can, so that's a bigger loss for the business, right? So they won't, book the orders. So then it's a loss, right? So that is the one of the bigger loss that you can give high severity, high priority. Because urgently they have to address that. Otherwise, so it will be a big loss to the business. Next, high severity, low priority bug. So basically, this happens when the bug causes major problems, but it only happens in very rare conditions. Low priority means not that much important, right? So severity means functionally broken. But no, there is alternative workaround for that. Suppose if you see customers who use very old browsers cannot continue with their purchase of a product because the number of customers with very old browsers is very less. It is not high priority to fix the issue. But the thing is they can upgrade and they can use the website. So there is no issue there. So that is what this high priority, high severity one and high priority, high severity, low priority. Okay. Next, high priority, low severity bug. So, for example, in the application logo or name of the company is not displayed on the web page, then this is very important, right? So it is important to fix that issue. as soon as possible before release. So it is not causing any damage, but still, so it's unprofessional, right? Without logo of the company, how can people will recognize whether it is a genuine website or not? They cannot trust it, right? That is the reason, this low priority, high priority, low severity bugs. So this is the main reason. If you know, very important, even though low severity, very important thing is there, you have to fix it. Then low priority, low severity bug. So not that much important, not a functional bug. Then, so you can fix it later if you don't have time today. If you fix, if you have a time, no issues. Both are okay. Okay. But not a so big demand from the customer point of view. So what is this? For example, the bug doesn't cause a disaster and only affects very small number of customers. Both severity and priority are assigned low. For example, a privacy policy page takes a longer time to load. So not many people view the privacy policy, right? So we won't read much. Slow loading doesn't affect the customers. So that's the low priority, low severity bug means. So what are the different defect tracking tools in the market? As I already told, Jira, Bugzilla, Quality Center. So these are the main, but Jira and Quality Center is very famous for reporting the defects. So nowadays a rally also coming. So what is a Jira? So Jira is a software, tool where you can manage all your project needs. So the project needs you can manage. So and you can so track your issues. You can track your defects, and you can maintain the requirements, the user stories with this within the Jira. So Jira provides Kanban dashboards and manages a complete Agile process. So you can manage the Agile process. So if you want to manage the Agile process, you can do that with a Jira tool. So that's the Jira tool, and you will get like this. Let me show. This is the how. So task we showing, right? One so line. Each these are the different states. So these are the different states. First, you have so this is Agile board, we call this. Agile board or Kanban dashboard, we call this. So basically what will happen is all the stories that are taken from the product backlog, it will be taken to this particular sprint. So first when all the stories will be in the to-do list. So if you started working, it will move to in progress. Then there are many states you can manage here. Then in progress, then development completed, deployment to QA, QA in testing, and then done. Definition of done we will call that. So that is how you can get. So this is the Jira defect workflow. First it will be in to-do list, then open, then in progress, under review, final approval, done. This is the all different. This is the life cycle of defect life cycle. So any defect, if you file, first it will be in the open state. So if the bug is valid, and it will be assigned to the development team. Here also you can assign, but again in the defect triage meeting will happen. Defect triage meeting means, so I told you right, every day you are raising bugs. So to discuss that defects, whether they are valid or not, there will be a defect triage meeting or bug report meeting, bug meeting, right? So there you can discuss whether the bug is valid or not, or it is not in your plate. The developer says it's not in my queue and it should go to a different team. So their team might be causing the issue. So you have to assign to that team and you have to follow up. Again, send a mail. So that's how you can assign the dev, to the dev. So here the to-do list will be there. And then he will move that to in progress. Once he take ups and he will make it a status as in progress. So then you can change in progress after you worked it and you fixed the defect and you completed the dev. Then you will move to testing. So once the testing is done, if testing is passed, you will close the defect. If testing is failed, you will reopen the defect and you can assign to same developer. So that's the complete bug life cycle. If the bug is not valid, so it will be invalid or duplicate bug, you can mark it. Invalid means I already told yesterday. Maybe mistake misunderstood by the tester or incorrect test data or so environment was down. Such cases you can so mark them as a invalid or duplicate. Duplicate means already this defect was raised by some other person. Again, you raised. First, who raised the other person? You raised it late. So such cases, you can mark that as invalid. So only first one will be considered, and second one will be marked as a duplicate. So this is the duplicate bugs. And if the duplicate means, you will close that. Only one defect will be taken care of. So that's the defect life cycle. This is one of the famous interview question. So you have to tell, these are the points you need to tell. So what is a defect life cycle? So defect life cycle means when, so there is a defect and so defect beginning to till end of the defect. What are all the statuses it undergoes is called defect life cycle. So when you report a defect first time, so it will be in open state and then it will be assigned to the development team. So maybe while reporting the defect itself, you will assign to particular development team. So then if it is accepted by the development team, then you can assign to the developer and you will change the status to in progress. If you already started working on that task, you can move it to in progress. Once in progress, the fixed dev completed and testing, right? Testing is in you need to retest it, right? That's a retest. So that is a retest. So retest is nothing but testing the fixed one once again to ensure that it is working fine. That's the this retesting. So in the retesting, if it is working fine, you can close that defect If it is not working fine, you can reopen that defect, assign to that same developer. So this is the bug life cycle means. Any questions?
No, good so far.
Okay. So you need to explain all these different statuses. When they will move to in progress, when they will move to fixed, when they will move to reopened. So all these statuses, you should be aware of that. And let me explain about ALM. What is ALM? ALM is again is another bug tracking tool. Okay, so another bug tracking tool. So it is used to track the tasks, track the defects, and track the project management. And basically, it's a commercial tool. You have to pay. Okay, you have to pay the money, but not you means not you, by the company. It's not an open source tool. So what are the different tabs will be there when you log into the ALM? So when you log into the ALM, you can see a dashboard, management, requirements tab, testing tab, and defect tab. So these are the different tabs you can find in the ALM tool. So in the testing tab, there is a test plan tab and test lab tab. Test plan will create a test cases. So test plan will create a test cases based on the user stories. Test lab, you will pull this test plan test cases into test lab, and in this while pulling, you will create one more here, test set. Test set you will get. In this test set, what are all the test cases you are going to execute, and those will be pulled to the test set. So in the test set test cases, you will execute in the test lab. Test lab is an environment kind. So you will execute the test cases. Then you will mark status pass or fail. That's a test lab means. What is a defect? A defect is a difference between actual and expected values is called a defect. So these are all the main points, and your Zira also looks like this. This is the one. So every person in this particular sprint, this is the one sprint dashboard. One sprint dashboard. Next sprint, then new things will come. New things will come. So that is the how Jira works. Any questions, Sanjay?
We're good so far.
Okay. That's all about defect and defect life cycle and different type of defects. Okay. Any questions?
Good so far.
Oh. So what is a manual and automation testing differences? We already discussed a few of them. Yes or no? Did we discuss anything about manual and automation testing?
Not that I can recall. We meant
okay. In the I think beginning.
To, yeah.
Yeah, in the beginning we discussed a little bit.
Okay,
it's okay. So no, don't worry. So manual testing means it is done by a person. In person, you will do by clicking a particular element in the application, and so that's what the manual testing. So it is a very expensive. It requires someone to set up an environment, execute the test cases. All this, it can be done by human, and there is a chances of failures, right? There is a chances of failures. There is a chance of failures. And those failures, okay. So again, to fix them, it will take some time. So that's why manual testing is a bit slow and tedious task. So automation testing, other hand, so those are performed by a tool. So that executes the test scripts, so which are written in different programming languages and repeatable tasks. Repeatable task you will automate. That means all the regression test cases you will automate. So that's the automation testing. Automation testing is very quicker, right? So you don't need so more time, and also less human errors, right? That's the automation test cases. Mainly automation testing is, you need to run them in Jenkins. You need to run them in Jenkins. Then functional testing. So there are a different type of functional testings. Functional testing means you are aware of that. You will check the functionality of the application. Right? You will check the functionality of the application. Whether a particular application functionality is working or not, you can check it. So we have a different functional testings: unit testing, integration testing, system testing, user acceptance testing, and so smoke testing, sanity testing, integration testing, and so regression testing, retesting, acceptance testing. All these are different type of functional testing types. Okay. So you already know what is unit testing, what is integration, what is end-to-end testing, smoke testing, sanity. I need to answer. But smoke testing, what is meant by smoke testing?
Isn't it sort of like vague testing you do before you start actual testing? I
Mm-hmm.
don't know how to exactly explain
Exactly.
it. Yeah.
Right. So build a stability. You'll check the build stability.
Build stability, yeah, to make sure there are no showstoppers.
Yeah, no stoppers. That's a smoke testing. Okay. So regression and retesting I covered already. So then we have white box testing, gray box testing. These are different type of testing. So, all. So one by one we'll discuss. What is unit testing? You know unit testing, right? Unit testing is so basically part of code. So what are the code you have written? You means a developer. So he has to test it. And some companies you have to do unit testing. Some companies you have to depend on the other person. But no, you have to perform the unit testing on the application units, application functions. So that's unit testing means. So unit testing ensures that each part of the code, so developed in a component, and so each component you will test it. Each component you will test it. So that's a unit testing means. What is component testing? I already told component testing, right? I don't want to tell again. Integration testing also I told. Smoke testing we covered already. Okay. So even regression testing, right? Regression testing means you can see function 1 developed in the sprint 1.
Mhm.
When it comes to function 2, sprint 2, there is a function 1 and function 2. Function 2 is the new one and function 1 is the old one. So that means you have some experience, some testing already done on this F1. When it comes to F2, you can do testing of both combinedly. So that's the sprint Y is the so they will be checked, more regression testing will be performed. So that's the regression testing means. And sanity testing. Sanity testing is basically subset of regression testing. Subset of regression testing. And basically what it will happen is before release, okay? Before release, you can do quick